learn about dynamic programming algorithm. In the last DSA class, we have learned about the binary search algorithm. I hope you liked it, and today we are going to learn about the dynamic programming. Dynamic programming is a optimizing technique in which the brute force solutions are further optimized so that it satisfies the given constraint and does not give TLEs. In this technique, we maintain an array. It can be 1D array, it can be 2D array, or it can be a 3D array in some cases. We maintain the array and store the previous already computed values of subtasks. And now the current task is calculated, is obtained by using the previous subtasks values. Let me clear you again. Dynamic programming, the given problem will divide into many subtasks, and each subtask will be further divided into subtasks. Now the subtask value solution will be obtained from its subtasks, and we keep on dividing subtasks until we reach a base case, and we manually provide the answer for the base case. Now by using this given value, it will automatically compute all the sub values of the subtasks, and these all subtasks will again combine to give the solution of the original problem. So dynamic programming is can be done by two methods. One is memoization and the other one is tabulation. In memoization, we use recursion, and in tabulation, simply we use an array. Tabulation is very convenient if you just get habituated to it, and memoization is very simple, but it will be difficult to visualize, whereas tabulation is very easy to visualize. So, while solving a dynamic programming problem, you have to be clear of these two things. One is state and the other one is transition. State. I told you that in while solving the problem in dynamic programming, we store the values of each subtask in an array. So state is nothing but array. In this case, if we take a DP array, then state is nothing but DP of I. It means you have to specify that what is DP of I is storing. What is DP of I is storing. This is going to be our state. Storing. And transition. Transition is how we are going to obtain the value of DP of I using 0, DP of 0, and DP of I minus 1. Now, whenever you compute the value of DP of I, you already know the values of DP of 0 to DP of I minus 1, because these are the subtasks of DP of I. So, in 1D DP, DP of I will be computed using its previous values. If DP of I cannot be computed, it is unable to compute from these values, then we can't apply the DP optimization technique on that problem. Here I wrote the state and transition for the 1D array. It goes similar for the 2D arrays also. The state will be, if the DP array is 2D, then the state will be DP of I of j. That's it. And the transition will be how you are going to obtain the value of DP of I j using DP of 0, comma 0, and all such values to dp of I minus 1 j and then so on dp of I j minus 1. These values, by using these values, you're going to obtain the value of dp of ij. How the formula, like in such cases, it can be simply, if we take the 1D array, dp of I can be the maximum of dp of I minus 1 plus error of I, like that. So to explain this dp algorithm, I'm going to take the knapsack problem as an example and I'm going to explain you. First of all, let me clear you that what is a knapsack problem. A knapsack problem is a standard problem in which you will be given a knapsack which can hold up to the weight of W, and you will be also given two arrays W and cost, WT and cost. This WT will gives the weight of ith item, and the cost of I represents the cost of ith item. Now the goal is to maximize the cost of the items which are packed in the knapsack. But the knapsack can hold up to the maximum weight of W. You have to make sure that the total of the items that you have selected from the from the array like items should, the total weight should be less than or equal to W, cost of item. Now to solve this problem, we are going to use a 2D array in which the rows are going to be the size of the, either we can take this weights of I named this, the rows will be the number of items, and we use n plus 1 so that we can have an extra array for writing the base cases. Similarly, here the number of columns is going to be the W plus the maximum weight plus 1. Means we are using n rows and W columns. Now here in this case, let me define the state. In this case, the state will be dp of I of j. See, what am I going to store in dp of I and j is maximum maximum cost that can be achieved using first I items and the total weight of the items selected must be j. I think now you have got the clear idea about the state. State defines what is going to store in the ith element of the dp array. And similarly, transition. Transition defines how you are going to obtain dp of I comma j. Here in this case, if I want to obtain the value of dp, the maximum weight that I can achieve by using the first I elements with a weight of j can be, wait, let me tell you, using first elements and with a, okay. Now this can be achieved by directly taking the first thing dp of I comma j. Here dp of, in this place we can simply store the value of dp of I minus 1 comma j. Is it clear? Like if I have used my previous elements from 0 to I minus 1 and obtained a value of j with some value cost, with some cost, total cost c, let's say, then I don't take the ith element, then it is similar to taking the previous row value. So one thing is I can simply store the value of my previous row's total cost. This comes under ith item is not selected, and the other case when I select the ith item, then selected, then previously, like if I am in this case my dp of I plus weight of the ith item, when I select the ith item I can only take, when the total weight I can only take first of all I have to make sure that I should be able to select the ith item. That means if even if I take my the ith item of weight w of I, wt of I, my weight does not exceed greater than w, which we are going to check by using a if condition. Then after, now dp of j plus wt of j can be replaced with here j. Now this value can be replaced by dp value of I comma j plus cost of, if it is cost, let's say cost of the ith element and whatsoever the total cost of dp of I comma j. I hope you understand my solution. Let's go to the any platform. So I'm selecting gfg and solve this dynamic programming problem of knapsack. So we came to the gfg platform and I have already took this problem. In this problem it's, so we are going to write the code and check whether our logic is correct or not. So I'm taking a variable int n which is equal to the size of, like this is number of items, and I'll take a 2D vector dp of size n plus 1 rows and capital W plus 1 columns, and I am going to initialize all these. So base case, what is going to be the base case? Initially, with without even taking one item, it resembles that I have selected 0 items and my total weight will be also 0 and my total value will be also 0. Now I'll run a for loop from I equal to 1 to I equal to n plus I less than n plus 1 I plus plus, and another for loop for traversing the columns j less than w plus 1 j plus plus. And in dp of I of j, first thing I told you that I can just replace this value with my previous row of equal j value. So I can just write here dp of I comma j is equal to dp of I minus 1 j, let's say a maximum of, even if there is already a value in dp of I comma j, then the maximum of these both will be taken. Um, and the other one is, first of all, we have to check that the weight j and j plus wt of I minus 1 should not exceed the value of w, and I can actually obtain that dp of I comma j. Means dp of I comma j is not equal to minus 1. In such a case, I can update the value of dp of I and dp of j plus 1 plus w of t minus 1 to maximum of whatsoever value already stored in the dp comma dp of I j plus val va of I minus 1. And finally we are going to return the max element of the n plus 1th column dp of n dot begin comma dp of n dot end of. And before running this code, let me check if I did any mistakes. I wrote the base case. This is the case of not selecting ith element, not selecting ith element. If I don't select, then I can just replace my value with my previous row's value. And this other case is selecting ith element. Ith element. If I select my ith element, I have to first ensure that the total weight is not exceeding the max weight of the knapsack, and I can actually obtain my current weight possibility. Then either if I can obtain that, then I'll go to the EP of that column, and here I have to take the value of my previous, like, and then we'll check. Okay, and I hope I didn't make any mistakes. Let me run this code. Okay, it's giving correct output. Then without any further delay, let's submit this. Okay, nice. It got solved. Okay, good. So this is how you're going to solve this knapsack problem. I recommend everyone to try again with the same logic. And after doing this, you take another problem of the dynamic programming and solve. because if you don't solve after some days, you're going to definitely forget. So I highly recommend you to everyone to solve this problem. Only watching the tutorials is not enough. You have to solve by your own. And I hope you like this video. And if you like this video, hit the like button and subscribe to get the notification of this placement related content. Thank you for watching.